So, Kamakshi, you are there, Dr. Kamakshi Sridhar?
Yes. Hello. Good morning, everyone.
Sure. Let me just briefly introduce. So, Dr. Kamakshi Sridhar is with Mavenir. I think there are, Mary, you talked about Mavenir. Somebody talked about Mavenir in the past. So, obviously, Mavenir is a big player in Open RAN and other core technology. And so, Dr. Sridhar, she's also a prolific inventor with 60+ patents. And you were in Nokia before that, Sandvine. So she'll be talking about what's going on in Mavenir and aspects of Open RAN. Take it over, Dr. Sridhar, and you have 20 minutes. Thanks.
Thank you. Well, thank you very much for this opportunity to speak. I would have loved to be there, but hopefully next time. So as our previous speakers have mentioned, Open RAN is now being deployed across the world. Really in Dish we are deployed, and Mavenir is a provider of Open RAN and Open RAN solutions, Open RAN compliant radios. And we are the only end-to-end cloud native network software provider with end-to-end connectivity. So we offer Open RAN, packet core, solutions that can be deployed on public cloud, private cloud, and so on. Should I share my slides, Dr. Astosh, or what would you like?
You should share your slides, yes.
Okay, so
if you have your slides, or if you want us to do, then we can share. You just have to say next.
Okay, I'll just maybe if you could share, that might just be easier.
Yeah, so Sam is going to do that. Then you can just have to say next then.
Okay. So yeah, Mavenir is deployed, and we are also in the forefront of standards. One second, please.
The slides should be coming
maybe.
Up. Yeah, so the slides are up. If you just have to say next.
Okay. Yeah, one second, please. I'm just trying to turn this off here.
You just say next, I'll take care of it.
Okay, very good. So Mavenir is at the forefront of Mavenir is at the forefront of Open RAN. We are involved in driving standards. We are involved in, obviously, our solutions are deployed both in 5G SA networks, both for TDD and FDD. And these deployments are continuing to grow. So today, what I'd like to do is motivate how Open RAN in 5G is really setting the stage for operators to look beyond and start delivering 6G services. So today, as operators are rolling out, please next slide. Yeah, as operators are rolling out 5G services, it offers such as, for example, fixed wireless access, NTN services, network slicing. We can get a glimpse of what is possible with 6G. And with 6G, you begin to, one second, please. My screen is, my apologies, my screen is kind of frozen, but please, yeah. Yeah, so operators are beginning to see the different kind of 6G services that's possible. Everything from immersive and interactive communications to integrated sensing to digital twins, networks that bring in AI/ML components and so on. And what's interesting is these applications require both high throughput and very low latency, very high reliability. And underlying all of these aspects is the need for networks to have some fundamental building blocks that support these capabilities. First of all, they need to be programmable In other words, they need to be instrumented in such a way that these network functions can scale dynamically based on traffic patterns. They can be instantiated right away. The services need to be disaggregated. The services need to follow what I call as the distinct network functions need to be deployed and scaled easily, and the network functions need to be deployed as microservices that are stateless and communicate via a service-based APIs. And that's needed because the range of services is very diverse, as you can see in the top, with also the integration of NTN into the play. So that means there is a need for flexibility, agility, and as we begin to think about the architectures needed to support it, we find that Open RAN today already has many of these tenets built into it. So if you could please move to the next slide. So 6G is going to be a converged, integrated, intelligent network. And let's delve into what that really means. So as we go from 5G to 5.5G, you're now beginning to see the transition from 5G to 6G is via 5.5G, where you're delivering both higher downlink speeds. You have a more uplink-centric design, where you're going to see a lot more uplink traffic. There's obviously much lower latency, higher reliability, large number of devices need to be supported. And on the end, these networks need to be energy efficient. They need to consume less power. So there are a lot of advancements that are happening on the RAN side and on the core side. On the RAN side, you have extremely large antenna arrays. There is integrated sensing and communication. And also, on the other hand, your support for RedCap and passive IoT. On the core side, we'll begin to see a convergence of the RAN and the core architecture, which then leads us into 6G, that'll offer ubiquitous connectivity, that'll have AI natively built in from day one. So in 5G, we are beginning to see with Open RAN the integration. We're bringing AI/ML closer into the RAN with both the non-real-time and the near real-time RIC that can optimize the operation of the network to support different use cases. We're also seeing focus on integrating sensing and communication. What does that mean? Where you can start sensing, sensing to see which parts of the spectrum are available for use, and communication to be able to use that. So 6G is going to be a convergence between wireless and wireline with intelligence baked in all the way and on where intelligence is both in the data centers, but also pushed out to the edge, where AI/ML models can be deployed and orchestrated in a very dynamic manner. So when we think about this kind of flexibility gives the network the agility to support all of the different services that we talked about on the previous slide. So if you can please move on to the next slide. So 6G, Open RAN today and 5G is already beginning to address many of the capabilities that will be needed in 6G. For example, the support for massive MIMO is already baked in, right? We already have intelligent beamforming techniques that are supported in Open RAN. The system architecture in 6G with the integration of AI/ML and with the service-based architecture being in play on the 5G core, and now slowly moving into the Open RAN. On the on the SMO side, we are now talking about decoupled SMOs, where all of the different functions within the SMO will be talking over a service-based interface. Then we have not only the interoperation, but integration of NTN with the bent pipe approach. We'll now see NTN, Open RAN work interoperate with NTN, where you may have the DU be deployed on the satellites for depending on the use case. Then you obviously have disaggregation. Open RAN is disaggregated, which means the CU and DU are disaggregated functions that can be deployed anywhere, either on-prem or in the cloud. And there's a disaggregation between hardware and software. And the open fronthaul allows you to mix and match radios from any vendor in order to support all of the different bands that are needed, particularly as we move into terahertz communication. So open fronthaul is a very key capability that will allow the support of the myriad of radio types. And then there is spectrum sharing for peer-to-peer use cases. Distributed compute is another very important aspect. So even within the VDU, if you look at, you can put your compute anywhere. Parts of layer 1 can be on GPU, layer 2 can be on CPU, and this GPU can be in the cloud. So there's a lot of potential. Not only potential, there's actually a lot of focus within Open RAN on making it completely open, both horizontally and vertically, and being able to leverage the investments being made by large chipset vendors in order to ride the energy efficiency capabilities and the higher compute speeds that are offered by them. So the other aspect that's really important in Open RAN that enables us to look beyond 5G into 6G, and it's already happening, is cross-layer optimization. So what does that mean? So traditionally, we think about Release 15 have brought in AI/ML intelligence into the packet core. Then with the O-RAN Alliance, you see the non-real-time RIC and the near real-time RIC. But there is also intelligence to be shared and optimization for end-to-end services needed between the RAN and the core. So so far until now, the EMS, the OSS layers tend to be legacy ones. So now these layers need to be opened up and instrumented in such a way that it allows for end-to-end automation needed to support network slicing use cases. So in order to assure SLAs for different network slices, you will need to support end-to-end optimization. And those capabilities are already being provided by Open RAN in 5G today. So if you can please move on to the next slide, please. So Open RAN is a foundational building block for 6G. As the previous speaker noted, it's no longer a nice to have, but operators are seriously exploring Open RAN, particularly given the maturity that it has obtained now. It has gone beyond it's an interesting concept to something where we have practical deployments and real issues have been addressed, both in greenfield and now into brownfield. So within these standards, Mavenir is leading some of the work in ensuring multi-vendor spectrum aggregation. Where we can interoperate with traditional RAN vendors in order to aggregate the spectrum between different vendors, between Open RAN vendors, traditional RAN vendors, and that will require us to possibly open up new interfaces such as the D2 interface in order to ensure that we get full benefits of the carrier aggregation capabilities. So On this slide, I have laid out all of the different principles of 6G from an architecture perspective that Open RAN supports already and can be used to help operators move into 6G. So first of all, it supports a multi-vendor ecosystem with openness, allows you to mix and match, and allows more innovative solutions with smaller vendor players to participate and bringing their innovation. The disaggregated nature of Open RAN allows you to really distribute compute, storage, resources across the network, across the different interfaces. And
Dr. Sridhar, you have 5 minutes to finish. Thank you.
Okay, sure. Yeah, just no problem. So we have disaggregation and interoperability across open interfaces. The open fronthaul interface allows you to support cell-free massive MIMO, cell-free distributed massive MIMO, and that allows you to give uniform coverage, seamless mobility. That's really the key. You have to ensure high user quality of experience, seamless mobility. The RIC, the RAN Intelligence Controller, plays a very key role in optimization, and this concept is the immediate use cases. One of the key use cases is energy savings, where you can decide which cells to shut down when based on traffic prediction and saving significant amount of RU power that's consumed. The XApps and RApps hosted on the RIC allows very many use cases. There are close to 21 use cases specified in ORAN Alliance, and these are growing. And what's interesting about these use cases is they benefit from the observability observed. So because you have visibility across the via the E2 interface, you have visibility, you're able to collect both the cell level data and the UE level data in a continuous manner. You can take closed loop control actions to facilitate many of the use cases. The O&M system is now open. It needs to have you need to have, for 6G, it's absolutely imperative to have the O&M system be programmable, and first steps have been taken. Open Merchant Silicon allows you to bundle different industry vertical solutions with ubiquitous connectivity. So Open RAN has standardized the internal interfaces within VDU, such as the FEC offload and inline accelerators, so that it gives you a variety of different options and allows you to pick and choose based on the scenario that's interesting. Then we talked about cloud native aspects, and the benefits of cloud native solutions are very clear. Then you have AI ML natively built in and across the network, and variety, and AI as a service is going to be absolutely fundamental to 6G. And then we are now able to bring in edge compute closer in. So MEC is enabler of many of the delay sensitive applications such as AR/VR. So MEC and Open RAN will together will be a very powerful combination to help support 6G applications. Moving on to the last slide, please. Yeah, Open RAN is built in to allow common AI/ML processes for end-to-end orchestration. So you can put in AI/ML workloads wherever it's needed, depending on the hardware, built based on the COTS hardware or based on any flavor of hardware that's available. And the training of the models, AI/ML, one thing people, we all should keep cognizance of is that the training of the models is separate from the inferencing of the models. The inference models can be deployed anywhere. Where you train the models depends on what data is available, where it's available, and both 3GPP and ORAN Alliance are doing some very important work in ensuring the maturity of AI/ML and bringing it to 6G. So all of these aspects are today happening in 5G as we speak, which makes it really easy for operators then to pivot to 6G. And may I go to the last slide, please? So Mavenir, to sum it up, Mavenir is building 5G solutions with Open RAN today, with open interfaces that are interoperable, AI-driven, cloud-native, and that support programmability with end-to-end automation capabilities that's delivered on any cloud. And that really helps operators be able to look ahead into 6G.
Thank you. Thank you very much. Let's give a big hand.
Thank you.